Hello everybody, I'm back with my continuation of my last video on how to go about solving ACT problems that ask you to solve for variables or ask you to substitute variables that have already been given values. In this video we're going to go through questions 11 through 19, so 9 questions. This section is going to expand upon the fundamentals we focused on in the previous video. This section is going to be more of your on the 1 through 3 scale. They're going to be your hard ones, mid twos. They're going to be pretty medium level questions. So let's get started with number 11. What is the value of a squared times b squared plus 2b over 6 minus a, that is a cubed, times c, if a equals 2, b equals 3, and c equals 4? So off the bat, they're throwing at us a lot of variables. Now, the good news with that is that at the end of the question, they give us these values for the variables. So the essential idea of this type of question is going to be plug and chug. So let me just write that right there. Plug and chug. Which should be an easy process. You can go about this either through a calculator, or if you're confident enough with your math skills to the point where you don't need a calculator, you can solve it manually. I'm going to solve it manually because I don't have my calculator here with me right now. So let's do this. A squared. A equals 2, so 2 is going to be substituted for A, times B squared. B equals 3 is going to be substituted, plus 2B. I'll erase this plug and chug. It's getting in the way of my arithmetic. Plus 2B plus 2 times 3 over 6 minus A cubed, 2 cubed, times C, 4. So after doing all of your plugging in, this is the expression that you're left with. And after you're left with the expression, you can simplify it further by evaluating all of these numbers you have with exponents. So 2 squared equals 4 times 3 squared, 9, plus 2 times 3 equals 6 over 6. So 6 over 6 is going to equal 1. This looks a bit messy, but we can work with it. Minus 2 cubed, 2 times 2 times 2, that equals 8, times 4 by itself without the exponent. And this is the part 2 of what we're left with. But of course, we still need to simplify this more because this is not the entire answer. So let's simplify this more. 4 times 9, that equals 36, plus 1 minus 8 times 4, which is 32. 36 plus 1 equals 37. 37 minus 32 equals 5. Your correct answer is going to be A, 5. So with this type of question, all you have to do is plug it in and you would have gotten the correct answer. The process might go a bit quicker with the calculator, but always with calculators you have to be pretty cautious of plugging in numbers that require sort of decimals, as in right here, because any small mistake and you're left with any of these false answers. But let's continue with number 12. So number 12 looks pretty straightforward. What is the value of 1 over m if m equals 1 over 6? So it is a straightforward question, and a pretty easy one at that. So what is the value of 1 over m if m equals 1 over 6? All this question is asking us to do is plug in 1 over 6 for m. When you do that, you're left with this sloppy simplification, 1 over 6. It looks sloppy, but you can simplify this by dividing it, by setting it up this way. 1 over 1 divided by 1 over 6. This is more simpler to work with. I know I feel that way. And whenever you're dividing fractions, you're going to do the reciprocal. So 1 over 1 divided by 1 over 6 turns into 1 over 1 times 6 over 1. You're left with an answer of 6, which is answer choice J. That was a pretty easy question. You could have solved that one in your head, or manually or with the calculator. Either method works. You just want to choose the method that gets you to the answer quickest and the method that you're most comfortable with. So let's get on to number 13. Number 13, if x equals 5, then 3x squared minus x minus 4 equals what? So this is another just plug and chug question. It's not asking you to do that much. They've given you a value of 5 for x, and when they want you to evaluate the quadratic given, all they want you to do is plug in the value they're giving you. So let's plug in x. 3x squared, that's going to go into 3 parentheses 5 squared minus x minus 5 minus 4. When you simplify this, remember to keep GEMDOS in mind. So you're not going to do 3 times 5 squared. You're going to multiply 3 times 5 squared. So this is its own little group. And when you do that, you get 3 times 25, because 5 squared equals 25, minus 5 minus 4. That simplifies down to 75 minus 9, which you do not need a calculator for. The answer is going to be 66, which is answer choice E. So a lot of these fundamental problems don't require you to use a calculator as much, but if you don't trust your manual way of going about solving the problem, calculator is always useful to have. Plus, with calculators, they're quick and easy to work with. But let's move on to number 14. Number 14. Which of the following inequalities characterizes all values of x where the inequality negative 3x plus 9 is greater than 2x plus 34? So with the idea with this question and with the question you saw in part 1 of this video is that we're just going to treat the greater than sign like it's a regular equal sign. And when you treat the greater than sign like it's a regular equal sign, this doesn't turn into a convoluted process. It becomes just a regular rudimentary algebraic equation that you're going to solve. And what that looks like is just this. You have your equation set up, and all you want to do is substitute whichever value you want to solve for. So for the sake of things, I'll just isolate the 34, and I'm going to subtract 2x to both sides. When I do that, I get negative 5x plus 9 is greater than 34 on this side. And then when I've done that, I'm going to now isolate the negative 5x. So I'll subtract 9 to both sides. When I do that, I will get negative 5x is greater than 25. And when you get to this part, it's important to remember that whenever you're dividing to both sides a negative number and you're working with inequalities, the inequality is going to flip sides. So with this example, we're going to divide both sides by negative 5 now because we're trying to solve for x. And when you just divide both numbers by negative, such as negative 5, you have to remember to flip this. So now the greater than sign is now going to become a less than sign. And 25 divided by negative 5 is going to equal negative 5. And this is going to be your correct answer. So G. The key to this is just remembering to look at the greater than sign like it's a regular equal sign and to not complicate things. That was pretty straightforward. But let's get to number 15. Number 15. Which of the following expressions solves 2z minus k minus q is less than 3p plus z minus q for z? So what this question is asking us to do is to solve for z, essentially. We can do that either one of two ways. We can isolate the negative q to the left side, which looks pretty difficult, or we can just move the q, or we can just move the z that's on the right side to the left side, and then isolate it from there. I'm going to go with the latter because that looks like a more simpler way to go about solving this. So let's get started and let's isolate this z. So on the right side, you have a plus z. So we're going to subtract z to both sides. and it's going to cancel out the z on this side, and you're going to be left with z minus q is less than 3p minus q. And since you haven't completely isolated the z yet, what you want to do now is isolate it by taking away the q on the left side. So in order to do that, you're going to do plus q to both sides, which actually cancels out the q on both sides. So you're left with z is less than 3p minus q plus q, that equals nothing, so that's just going to be 0. And this is the answer that you're left with. Z is less than 3p, which is answer choice E, I believe. That's how you solve that.